Okay, for the induction problems, we'll only worry about the inductive step. So in a problem like this where it says use induction to show that the sum is equal to this, we would be doing in our inductive step, we'd be assuming that this is true for the k case. So in other words, we would be assuming that, let's say when we plug in 1, we get 2 times 1 plus 1, which is 3, plus plug in 2 would be 5, plus dot 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 dot, up to the kth case, which would be plus 2k plus 1, we would be assuming that that would be equal to this assumption, or this part right here, with k times k plus 2. So we'd be assuming that this is the case. Notice, and then we would move on to the next case, which would be 3 plus 5 plus dot 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 plus 2k plus 1 plus the next term, which would be inserting a k plus 1 here, would be 2 times k plus 1, which is 2k plus 2 plus 1. So that'd be a 2k plus 3. And we wouldn't be assuming that that's equal to anything. We would be now looking to this and kind of hoping that it's equal to this with a k plus 1, but we don't have no idea. But by the induction hypothesis, since we assumed that these ones added up to k times k plus 2, we can say this is k times k plus 2 plus 2k plus 3. That's a k squared plus a 2k plus a 2k plus a 3. In other words, it's a k squared plus a 4k plus a 3. And can anybody at home factor that for me? Doesn't that come down to become a k plus, let's see, be a k plus 1 times a k plus 3. And if we look at that, isn't that the same as k plus 1 times k plus 1 plus 2? And that's exactly the same as this, but with k replaced with k plus 1. Notice the k has become a k plus 1, and here's the k plus 1 plus 2. So that's what makes the inductive step work, is assuming the inductive hypothesis and using that to prove the inductive step and rewriting it in those terms. Okay, so that's the top left corner. In the top right corner, write the general nth term of this sequence. So let's see, what do we got on the bottom? Let's see, they're not written conveniently now. Let me try to write this as 3 over 2, and then maybe 2 over 2, 5 over 6, 3 over 4. Now that's not very useful either. Can we see anything strategic here? Let's see, 2 to 4. Adding on a half. Okay, then let's try rewriting it in terms... Oh, maybe if we write this one as a 6 over 8, because then I see the 2, 6, 8. Oh, and then maybe this one as a 4 over 4. Yeah, there it is. 2, 4, 6, 8, 3, 4, 5, 6. So in order to write this one in general, I'd write an. Let's see, usually we start with n. These are just sequence of terms moving, so I'll go n plus 2. And then on the bottom, we need even numbers starting from there. So when I plug in a 1, that'll be a 2n. Let's check it. When I plug n equals 1, 3 over 2, good, 2, 4 over, yep, there it is. an equals n plus 2 over 2n. Okay. Write the general nth term of an arithmetic. Thank goodness we know this one's arithmetic if we know these two facts. So a sub 18, which is 122, is equal to whatever the first term is plus 17 copies of the difference. And the seventh term, which is 34, is equal to the first term plus 6 copies of the difference. So if I were to subtract these, 122 minus 34, 122 minus 34 is, let's see, about 88, I think. 88 equals 17 minus 6 is 11d, so d equals 8. And once d equals 8, that would mean that we would have from this equation 34 equals a1 plus 6 times 8, which is 48. So subtract 48. And what do we get? Looks like a negative 14 equals a1. So I got a1 and I've got the d. So if we want to write the general nth term, I'd say a sub n equals the first term plus n minus 1 copies of the difference. Or I might even write an equals, let's see, negative 14 plus 8n minus 8. I might write this as 8n minus 22. 8n minus 22. So let me check that. If I plugged in 7, it would be 56 minus 22, which is 34. So I'm pretty happy. Okay, good. For this one, find the first term common ratio and general term of the geometric sequence given here. So now we have the first term, which is negative 30, is the first term, sorry, the second term. The second term, negative 30, is the first term times the common ratio. And the fifth term is the first term times r cubed, right? So now if I were to divide the second equation by the first equation, going this way and dividing, we'd get 3750 divided by negative 30. 3750 divided by negative 30. Negative 125 equals r cubed divided by r to the fourth. That was a misprint because a to the fifth minus 1 is r to the fourth, and minus 1 is 4. R to the fourth divided by r is r cubed, so r equals negative 5. Once r equals negative 5, knowing that a2 equals negative 30 means that a1 times negative 5 equals negative 30, so a1 must be equal to 6. Okay, so that means the first term, a1, is 6. The common ratio, r, is equal to negative 5. And the general term, a sub n, would be equal to the first term times the common ratio raised to the power of n minus 1.